Hi everyone, I'm Ron from WIZ850 Hong Kong. Welcome to WIZ850 Hong Kong YouTube channel. Today's tutorial is about SPI interface. We will use W5500 SPI interface to communicate with MicroPython to communicate with a SPI slave module. If you wanted to know more about how to install MicroPython for W5500, you could watch our previous short videos. The links will be in the description below. In W5500, there are two sets of SPIs. Those pin information will be in .w5500.com. So let's go to have a look. In .w5500.com, the EVB pin description, the SPI interface will be shown in light blue. SPI 3 will be working with PB3 to 5, and SPI 1 will be PA5 to 7, and today we will focus on SPI 1. SPI 1 PA5 will be the clock, PA6 will be the MISO, PA7 will be the MOSI. And we will also use the chip select pin that is with PA4. Let me show, okay, in PA4. Okay, so back to the board. In the board, as you can see, the board has connected everything already, and it connects with a WIZ850io module. This WIZ850io module is actually a module that using W5500 chip, and actually WIZ8's W5500 chip is a SPI slave chipset, so it's actually converted into a module version. So mainly we are communicating with the W5500 chipset through SPI. About this information, actually you can go to our .wiznet.io, go to modules, Ethernet modules, and then WIZ850io. All the pin description will be provided in this documentation website. The most important 5 pins will be MOSI that needs to connect to the board's PA7 pin. The clock will be connected to PA5, and then the chip select will be connected to PA4. The MISO will be connected to the PA6. And finally, the reset button that I will choose to connect it next to the chip select pin, that is PA3. Why the reset button is important? Because the reset button the module needs to be reset first. If not, the module cannot operate normally. Okay. After that, I need to explain further about some information inside the W5500 chipset. So we need to go to the datasheet of W5500. So the first of it, we need to go to page 12. Okay, page 12 will mention about the SPI mode that supports in W5500 and how to connect. Simply to mention about how the connection works. After that, we go to page 14. Page 14 will mention about the SPI frame. How does it set the data, and how do you send it, and how do you receive back the data through SPI. And another important thing is which register that we could test. I would recommend we could test the chip version register, because the chip version register is always constant. The return value definitely will be 04, and the command that sends to the register is always the same as 0039. So this is the best register for us for testing the SPI Is it working correctly? And is it communicating with W5500? Okay, so let's try to write some script. Okay, as you could see, W5500, we are in Thorny again. Okay, in Thorny, in MicroPython, in more specific, the MicroPython in W5MH32, the SPI interface is actually in machine. So as usual, we just from machine, and then we import SPI, and then we need the pin as well. The pin is used for creating the chip select and also the reset. After that, we need to have import time for creating some time delay for the reset. Okay, now we try to create a SPI, a variable called SPI, and using SPI module, we are using SPI one that I've mentioned, and then the baud rate we need to set. Just for this example, maybe we just set to 5 million. So this will be the frequency. Oh, sorry, 5. The frequency in 5 million. After that, we need to set the polarity is equal to 0, and then the phase is also equal to 0. Done. So what are these two? This two is just setting the mode. For polarity 0 and phase 0, it will be mode 0 for SPI. After that, we set the CS pin. CS pin will be pin, and then PA4, pin output, okay, pin.out, and then the reset will be pin PA3, also pin out. After that, we need to start to do some reset by controlling the reset pin. Okay, so the first thing is reset value is 0. We turn off the reset pin and give a time delay time. Sleep millisecond for 10. Afterwards, I return it on, and then time sleep for 200 milliseconds. So this is how it resets the W500. After that, we need to control the chip select pin value to 1 for deselecting. After that, we could start reading values, but the first thing we need to select the pin by providing a low level signal. And SPI, we write something to the SPI, so it will be byte AI away, and then brackets to 00, 0x39, and then 0x00. This is the format that I mentioned about. So it will be the command, and then and this is the return. So command and control. If you want to know more about it, how to send the data correctly through SPI, just read our data sheet. After that, we just print SPI read, and then we just read 1 byte from the W5500 chipset. After that, we just CS value, CS.value, and then we change back to 0. I change back to 1 to deselect it, and the SPI operation should be fine. So let's test it right now. As you could see, the return is 04, that means the SPI interface has been created correctly and it is really communicating with the W5500 chipset in WIZ850io. So this is the most simple way to communicate with WIZ850io using SPI interface. We will continue to create more kinds of MicroPython tutorials based on with W55MH32. Stay tuned. Thank you for watching.